Welcome to solverfy.
This problem deals with adding vectors together to find a resultant displacement vector. First, we can separate the three vectors into their x and y components. For the first vector, we see that it has its x component is 200 and its y component is 0. For the second vector, we can see that its x component will be 135 times the cosine of 30, and its y component will be 135 times the sine of 30. And when you plug that into your calculator, you get that the x component is 116.91 meters, and the y component is 67.5 meters. Next, for the third vector, its x component will be 135 times the cosine of 40. Next, its y vector will be negative 135 times the sine of 40. Now, it's negative because it is going in a downward direction. So, its x component, when you plug into the calculator, will be 103.42 meters, and its y component will be negative 86.78 meters. Next, we can add up the components of all three vectors, which leaves us with a resultant vector that has an x component of 420.33 meters in the x direction and negative 19.28 meters in the y direction. Then we can find the magnitude of r using the Pythagorean theorem. We know that the magnitude of r will equal the square root of 420.33 squared plus negative 19.28 squared. This gives us a magnitude of 420.77 meters. Next, we need to find the angle. Looking back at our triangle, we can see that we can find the angle using the tangent function. Therefore, we know that the tangent of theta will equal negative 19.28 divided by 420.33. Now we know that the angle will equal the inverse of tangent of negative 19.28 divided by 420.33. And when you plug this into your calculator, we get that theta equals negative 2.63. So, putting all together what we did, we can see that the resultant displacement vector will have a magnitude of 420.77 meters in the direction of 2.63 degrees below the horizontal.